Hello and welcome back from the workshop. Our next speaker is Dr. Robert Bott from Purdue University. Dr. Bott will be talking about software libraries for agent-based modeling and models of interactive shooters. It's very interesting. So please welcome Dr. Bott. Thank you.
Well, hello, everyone. One quick correction already. I'm not yet a PhD. PhD candidate, hoping to finish off this semester, actually. Today, I will be presenting our model in a library that we created for AnyLogic to help create faster and better active shooting event models. Myself, Robert Bott, I'll be presenting. Other members of the team were now PhD Braden France and Dr. Eric Dietz. So I'll just get started. So quick agenda. I'm going to talk about real quickly about the objectives of the Purdue Homeland Security Institute, the PHSI, of which we all belong to here at Purdue. Quick background on the problems, including active shooting and why we created the library. Research and the example model, significance of our research and what we do at the PHSI in future work. So real quick, our director, Dr. Dietz, also my chairman on my committee right now. He is a fearless leader. And what we basically do is we measure and we optimize emergency response, not just active shooting incidents, also things like evacuation and times and efficiencies. I personally am involved in the active shooting incident research, and we support policy and policymakers here at the PHSI. Anything that we can produce, any data we can produce that helps them make better decision and implement better policy to help their various institutions as well as their cities and their governments. So a real brief background on active shooting incidents. Could talk about this for hours. There's a lot there. If you've watched the news over the last couple decades, you've seen a lot of this active shooting incidents, particularly in the United States. According to the FBI, we've had 332 active shooting incidents between 2000 and 2019, 2,851 casualties, including dead and injured. One point to note is Columbine spurred research into new policies. And this is important for this particular model and the research we have done because we based our model off of the Columbine library that was modeled. What has happened since Columbine in the last 2 decades is we've created, not us at the PHSI, but as a country and as researchers and law enforcement, new policies and tactics and run, hide, fight policies and tactics for police. And run, hide, fight, for example, is one policy, one methodology for civilians. Just as the name suggests, you run, you hide, and you fight. A quick little story on that. I've heard recently that when people were in an active shooting like this, run, hide, fight helped, and the training helped to reduce casualties. There's a good argument can be made by that. There's other policies such as avoid, deny, defend, which is a different system, but similar to that. So that's a quick background on active shooting incidents. Regarding the library, well, primarily, why did we create it? Well, we do a lot of research in active shooting incidents, and like we said, emergency response and for first responders. And the problems we had is we keep using the same code in different models. We keep copying, pasting the same things. And any good software developer understands the issue of copy and pasting code. What we want is we want modules. We want components. We want that good object-oriented software development, the abstraction, polymorphism, inheritance, and encapsulation, all that good stuff. It's well established at this point. And that's what we wanted to try and create now for us at our institute. Code and algorithm optimization, I'll get into those details in a little bit. Retention of institutional knowledge and progress. We found that a lot of students come here and then they learn how to use AnyLogic, very easy tool to use, but I think it is very hard to master. And so we get to a certain competency level, and then that's where it stops. We do our research, and we don't really retain a lot of that inherent skill, as well as the code. Now, granted, copy and pasting, but again, the issues with that are understood. And so we wanted to create a foundation built on a strong API, on a strong interface towards whatever code and logic blocks we created. So real quickly, this is the model that we've created that we based on. This is the Columbine Library. One of our students, Jay Lee, who's now since graduated in 2019, he actually presented here at the conference in person in 2019. His model is still out there. His presentation is out there. I welcome you to look up Columbine and Jay Lee. This is the model we based on. It models the Columbine Library. Again, getting back to how important Columbine is. And this is a rather large model for us. It might not be as complex and as extravagant as I've seen some models out here. But again, we only have a certain level of competency in developing these models. And we look for the data, not for the 3D graphics and such. But rather large model. Admittedly, about a quarter of this is for our validation purposes. We always validate our models, but it is rather large. And we wanted to kind of cut that down. And also, when a new student comes in and wants to do something with Columbine or something similar that Jay Lee and us did, we don't want to force them to have to learn every little detail about the model. Yes, learn AnyLogic, but what things can be shortened in order for them to do research versus learning the intricacies of how to model. Although that is a learning experience too, we wanted to kind of shorten that. And so what we did is we took that model and we broke it down into what you see right here. It's significantly smaller, although ever since this model was created and published, the paper for it was published, more work has been done. Admittedly, again, about a quarter is not here, the validation pieces, yet it is significantly smaller, and we found we saved a lot of time remaking this model in the Columbine Library. One of the biggest pieces we've accomplished is what we call a line of sight algorithm, or the field of view. So when we have a shooter and they have a view of their area and they only have a little arc shape, which is of a certain diameter, a certain length, a certain angle, that's their view. What the previous model did, it had boxes laid down on the environment. So if you're in box A, you can only see B and C. If you're in C, you can only see A. And that's how we did what we call line of sight. Our work, we created something that does not need those boxes. So it's now independent of the environment you build. You can just pluck it into your model and you have a line of sight available, and you have obviously parameters, within the API where you can set certain parameters, larger field of view, longer field of view, et cetera, et cetera. That is the biggest piece, is the line of sight algorithms. And I'll talk about future work and things we already have done in a little bit. Just getting into that, object-oriented software development, in my background being in computer science, this is just an example of one of the classes. Again, it's expanded since this was published. So I had the person-based class, overridden functions where needed. We use this for responder and civilian types, as well as for the shooter. Again, I'll get into the details of what has changed, but this is the basic concept. Now, I found out in development that AnyLogic does not allow types to be exported yet. I heard they are bringing it in. I unfortunately had to miss the presentation this morning on AnyLogic 9. So we have the logic blocks exported, but at some point, we hope to be able to export this whole thing in a library that you import, just like the pedestrian library or, the Pathmind helper or whatever other library, as you should do in AnyLogic. And that will make it easy on our researchers, easy on new students coming in. We teach them the basics of AnyLogic, maybe some advanced things, and then they can get the researching with higher fidelity than they would if they had to spend time developing everything all over again. So I'm going to show a quick video. And it's a little small understood, but the things I want to explain about this is up in the upper right hand corner are the two red dots, which are the shooters. All the green dots are the civilians in the library, historically modeled. We have an arc of fire, which is essentially these little field of views, these line of sight elements, and the shooters can only see those. Can only see civilians within it. And when I play it, you'll see what I mean by that. So the blue dots are the responders, or the concealed carry weapons holders. As you see in this scenario, one of them dispatched a shooter real quickly. Shooter turns around, acquires a target, and dispatches a responder. Now a new responder comes in. The shooter is actually engaged now. The civilians. One of the things to pay attention to is how the responder does not see the shooter, because that's what the parameters were set up for. There's only that line of sight arc, and that's one of the significant pieces we implemented. And what will happen is the responder will take out the shooter, acquire it, take out the shooter, and the scenario ends. Just an example of all run. And now a quick example of all fight. In this scenario, I talked about run, hide, fight. In this scenario, all the civilians will actually run towards the shooters and try to fight them. Development that has happened since this is a higher fidelity implementation that actually acquires the position of the shooter quicker and more often. And as you can see, the scenario changes with all fight versus all run, but just another example of what we've done. And implementing this kind of line of sight before we implemented it took weeks, if not months, to do. And so that gives a significant shortening of what a new researcher has to do coming into our institute. So significance of the library, as I mentioned, saves time in model development. I think any software engineer or a developer or any scientist understands the use of libraries and reusing code through a well-made interface. So no expansion needed on that. It expedites model completion. I can now focus on other things, grander things, do better research and different research than reinventing the wheel. Hopefully fewer bugs in the models. I can't tell you that my code is perfect, but hopefully there's less bugs. Again, copying, pasting, having to understand things and redoing it always introduces new bugs. I think we all understand that. And then we can focus on the research and not the modeling complexities that much more. Eases the workload for less technical modelers. We've had a lot of individuals coming in here who don't necessarily have a technical background. They need to learn a lot and very quickly. If we can make it easier on them so that they can push the envelope forward as far as science and modeling, the more the better. So the significance of the PHSI, the Purdue Homeland Security Institute research, our value impacts, for example, in school resource officer presence. We've already published 2 models, 2 papers on how a school resource officer would have affected the Columbine incident in 1999. Same with the concealed carry permissions. Again, if a policymaker is looking into what would a school resource officer, an armed resource officer in the school, what impact would it have during a shooting? We have done research like that. Central warning announcement, door usage during active shooting incidents. Within the door locking and use, we've actually at Purdue, we had a shooting in 2013. After that, Purdue spent millions of dollars putting in really heavy doors with really sturdy locks. And this is because active shooting incidents, they last an average about 5 minutes. Every 10 to 12 seconds, there's a victim. And so our response times here at Purdue and within Tippecanoe County are very, very short, under 2 minutes. And if you can keep the shooter out of that room, that can save lives. And we've shown that in various research that we've done. Magazine capacity research, large event evacuation, again, getting into beyond just active shooting. I want to emphasize that we do a lot of that too, evacuating theme parks and large events. We do a lot of work with various events around Indiana. Staffing requirement prediction for evacuation security. I mean, if you have to evacuate for a hurricane, how much staff do you need? Just that kind of modeling. That we've had impact on that regarding a PHSI in our research. So future work and what we hope to accomplish in this, our vision. We've already done a lot of civilian logic improvement. Unfortunately, the research has stalled as far as myself, because my PhD research took me more into the realm of deep reinforcement learning, in particular using Pathmind right now. I know they're here too, great presentation stuff, good product. But we've done future work on that. And what we see us accomplishing with this library is essentially an emergency response library in the future. And the details of what that entails are still being looked at. But things like wound and medical modeling. For example, there's an active shooting. If you've been paying attention to the news, a couple months ago, there was a shooting in Colorado, the King Super. The police officer went in, unfortunately lost his life, but he did the right thing. He went in as the police tactics described, but then the police backed off, and there were many wounded in that supermarket, and we don't know how many might have been saved. And to model how important it is to get there and apply a tourniquet or trauma, medical trauma treatment, those kind of modeling, and then we can provide those to the library. Fire and rescue, high fidelity components, both qualitative and quantitative fidelity on weapons and equipment, wounding effects, different kind of weapons. And, that might be important to some certain kind of research that is looking at the different kind of weapon systems, as you can imagine. Well-researched and validated data as a default, that's kind of secondary, but providing that for researchers might be of value. But the main thing is providing that framework through the library. We're hoping to accomplish that as an emergency response library. So what's the value? Everything runs on money, and what's the value for somebody implementing this? Well, there's over 3,000 counties in 300 cities, above 100,000 people in the United States alone. There are a lot of smaller governments and mid-sized governments who don't have necessarily the resources. Anything that makes it quicker, easier, and cheaper for them is of value to them. It's just a matter of obviously implementing it and providing it as a modeling source. So modeling, contributing to policies, if a county government or a local municipality or a school like Purdue wants to know, hey, should our police officers carry and be trained in trauma medicine, how would that help? Well, you'd have to rebuild your entire model, not just the environment, but you'd have to build a wounding model, et cetera. If we provide that, that cuts off significant amounts of times. It contributes to that policy modeling. And that's where we're hoping to go with this. So again, streamlined modeling reduces costs and provides greater overall value. That's where we see this going and what we want to do with this. So a quick summary, as I talked about, active shooting incident need to be addressed. They are actually on the increase from in the last 20 years, according to the FBI. So again, our research, in my particular research, just focuses on, what we call in extremis, at the point of death, not prevention so much, but what can we do before the incident happens to prepare everyone for it and improve survivability. And so we're helping to address it with many other researchers in the country and around the world. As I mentioned before, modeling, aiding policymakers. I think that's for the audience here, kind of obvious, but hey, worth mentioning again. A emergency response library with various components, from active shooting to fire and rescue to medical modeling, et cetera, can help reduce those costs in that time and compress that time to push out better and models more quickly. And that's basically the summary of my presentation. And I guess we could do a Q&A real quick. Please feel free to contact me before we continue on with the Q&A. Myself, Robert Bott, feel free to contact me. Dr. Braden France and Dr. Dietz, they're happy to take your questions too. If you want to contact me and CC them, that's fine too. But please keep me in the loop. I'm the primary contact, hence why I'm here presenting. And as you can imagine, Dr. France is an active duty officer in the United States Marine Corps. So if you've been following the news, he's rather busy. So, but he'll happy to answer your questions too. It's just, I'm primary contact. So please feel free to ask. If I don't answer your questions or I can't, or I need to get back to you, that's the contact information. So thank you. Right, I'm being told there's no questions yet. Either I did an astoundingly good job or an astoundingly poor job. please, if there's anything you want to ask, even since we have the time, we got like 10 minutes regarding general active shooting incidents, or maybe even future work that I'm doing that ties to this with DRL and Pathmine. I'll be happy to answer those too, if there are no specific questions about the library. Okay, we got one question. What sort of behaviors for the shooter can your library define with its parameters? Right now, the shooter, it's a really good question, and that's future work. So behavior, we're looking into that level of fidelity as far as, how does a civilian act of a certain age and whatever. And right now, we haven't delved into that level of fidelity. However, the behavior of the civilian is at this point the most complex, if you want to call it that. We have behaviors of run, hide, and fight within those parameters of run, hide, and fight. And, the user through function calls and through the parameters can decide at any one point in the model to go from running away from the shooter to hiding from the shooter to fighting from the shooter. And we implemented this primarily because of Pathmind and the work that with DRL that I've been doing, over the last year or so. And so we needed the DRL to be able to decide an action. So behaviors as far as actions are in, behaviors as far as, the research of, children versus adults and what they do and if they panic or something, we haven't put anything in there, but that's kind of a fidelity, low level fidelity or high fidelity that we want to put in the future too. I hope that answers your question. All right. Doesn't seem like we're getting any more questions. Okay.